I'll start. So I'll first give you introduction for your A2, as in what to expect in your A2. It's very different from your AS, obviously, but the strategies will be different as well. Okay, so I get a round of what to expect. Right. So first thing is that we'll be having two of these books. So this is book one. This is like half and half. So the other book is exactly the same size. Okay. So the syllabus is split into two parts, and you have your textbook, which is going to be very important later on, just like your AS. So there's a textbook, the course book, right? So the Pore Lagbe. But before that, let's try to understand how is it different from your AS. So the biggest challenge that you have with your A2 is the volume of the syllabus. Okay, so these are all the chapters that you have, and these are chapters that you have never heard of. AS at advantage, you knew some of the stuff. You only had to build on them, right? I would say maybe 10-20% is something that you know, right? Rest of them is all new stuff, right? And you can look at the number of chapters out there. The number of chapters is such that we have to do like 2 chapters every month to finish the syllabus before your exam. Okay, so the volume is a lot. Is it difficult? Not really, in the sense that it's if you look at chapter to chapter comparison, right? I would say maybe A2 is a little easier because these chapters are absolutely new for you, right? So because they're new, they don't go into that in depth. But if you remember your AS syllabus, right? You're doing motion and mechanics for like the 5th or 6th time, right? So they had to make the questions complicated. You're going to learn about electric fields or capacitors for the first time ever. So they can't really give you the most complicated questions out there. So yeah, the difference is that the volume is a lot, right? And students start to usually falter around this part. So magnetism reach that's like how long your AS syllabus was, right? Airport students just give up because it's so much to study, right? So don't do that. If you can just stick to both, most chapters and get the basic idea of it, you should have a very good exam. Okay, now I'll explain why it's easy to do well in your A2 compared to your AS. I'll explain in a bit. But yeah, these are the chapters that we have. Amader target to obviously wrap this up by January, but January is difficult because I already told you the number of chapters is way too much, right? So we also have to start earlier. We start July, otherwise our project start project. But still it's late. We should have started in June. But I think you had exams in June maybe, right? So yeah, anyways, this is the syllabus. How are the exams? Your AS had 3 papers, right? Paper 1, paper 2, paper 3, right? This is a completely different. There's nothing similar to it. So it's a completely new way of examination. So you basically have 2 papers. Paper 4, which is the exam you'd say, and paper 5. IGCSE students might have some idea about this. This is similar to something that we had in our O-levels. It's alternate to practicals. Okay, so you don't have practicals anymore, but you have a paper that's called the alternate to practicals, right? So yeah, paper 5 and paper 4. So in terms of mark distribution and percentage of your examination, if you just do well in paper 4, right, you can get an A. So paper 5 is actually I would say redundant in the overall picture. Paper 5 useless paper. Okay, so even if you do well in paper 5, it doesn't really improve your grade. If you do bad as well, it doesn't really improve your grade. Okay, so yeah, or worsen your grade. So what's paper 4? Paper 4 is only structured question, so no more MCQs. MCQs are not there in your A2. It's 100 marks. Okay, it's a very comprehensive exam. So imagine your paper 2, right? 2 times. So do your guys together. The total number of questions is doubled as well. So one challenge that students face with this paper is endurance. You're not really used to, I don't know if you have other subjects where you have 2-hour papers, right? Usually AS it's like 1 hour, 1 hour 15 minutes. Suddenly 2 hours. I see some students halfway through, they're just tired. So yeah, that's the only challenge I would see here. 15-16 questions sometimes, right? So there's a lot of questions out there. They're all structured questions, right? And this part is the one that you should be a little careful about. You also have to know what for your A2 paper, your AS knowledge. Okay, so you have your AS materials that will come in your A2 as well. I would say that over the years, maybe basic knowledge is enough. Nothing critically jeta shikso lage. But yeah, the AS syllabus is part of your A2 syllabus. Okay, so basic circuits, projectile motion, vectors, they're all there in your A2 as well. Okay, not as much as your AS, but they're still there. And this is the total mark distribution. So it's almost half of your entire A levels. So it's actually pura A leveler হচ্ছে 38.5%. So 40% করতে পারো. So your AS A2 সব মিলে, this paper holds the biggest value. So you can turn around any grade using this paper. So if you have, like, let's say a B in your AS, right? This paper can make it an A star. Okay, of course it's going to be difficult, right? But it is possible. That possibility is still there. So yeah, because the weightage is a lot. But if you look at your AS, it's something like 17.5, 22.5, and 17.5. The distributions of the paper there, evenly distributed, right? But this one is like on its own, like the board paper, right? But if you see the other paper, it's like it's almost non-existent type of paper. So it's only 11.5% of your A levels, okay, like 10%. So even if you do full marks here, which students do all the time, right? It doesn't really change their grade. It changes their marks, like 85 থেকে ধরো 88 যেতে পারবা maybe, but it wouldn't really change your grade overall. Okay, what is this though? So this is planning, analysis, and evaluation. আগেই বলছিলাম, this is similar to your যদি IGCSE থেকে থাকো, there's a paper called Alternate to Practicals, where what did you do? There were information provided, you had to analyze them, right? This is basically that paper. Practicals are 9, so practicals এর হচ্ছে alternate হচ্ছে এটা. This is the easiest paper in A levels. Okay, full stop. I mean, there's no other comparison to this. I'll tell you why it's the easiest paper in A levels. It's because it's 30 marks, right? And to get an A star, you need to get how much? 27 out of 30, 90%, right? Etar হচ্ছে raw marks to get an A, right? Is 29. Do you know what raw marks are? Raw marks means তোমার actual exam এ কত পেতে হবে to get an A. You have to get 29. You have to actually get more than what A stands for to get an A. Why is that so? Everyone does well. I mean, almost everyone gets full marks there. So because everyone gets full marks, scaling it gets scaled up. Not just scaled down by every paper, right? So this gets scaled up. So yeah, I'm saying all of this because this is the easiest paper out there, and you shouldn't really bother about this until, like, let's say a month or two before the exam. Okay, because you can no return on your investment. You spend a lot of time here. Okay, so yeah, this is that paper. It is called paper 5, Alternate to Practicals. Just paper 5 bola hoy. This is about designing experiments. Do you remember designing experiments, planning experiments in your O level? So there GC থেকে ছিল practicals last question yeah, basically that. Okay, now what's the chapter on which you get your experiments? This is where it's a little tricky, but it shouldn't be. Eventually we'll prepare accordingly. Questions will come from where? Outside the syllabus. Okay, so they can literally ask you anything. Some of the most absurd questions out there is in this paper. Okay, they'll ask you to experiment the most absurd ideas out there, but you just need to plan it. You're not supposed to know the outcome of it. Do you understand? So yeah, you need to build the skill of designing an experiment and not actually do the experiment and come up with the outcome. Don't just plan to likhte hobe. Okay, so there are 2 questions there, 15 marks, 15 marks. Ekta planning theke, ekta graph theke. That's it. It's 1 hour 15 minutes. If you are average in this paper, you can finish it in 45 minutes. And if you're good in this paper, maybe half an hour. Okay, 1 hour 15 minutes karo lage na. Okay, so yeah, a paper ta will keep it away. Eta niye ar bother korbo na. Let's come to the paper that is the worst paper in A levels. Okay, eta hocche literally statistically this is the worst paper in A levels. I'll tell you why. This is a 100-mark exam, right? How much do you need to get an A star? 90 out of 100 in this paper, right? How much do you need to get an A in this paper? 80 out of 100, right? These are the scale marks. How much do you actually need to get raw marks to get an A in this paper? Over the years, right, it has been around 55 out of 100. So if you get 55 out of 100 in this paper, it's considered an A. Okay, the easiest paper that ever came, which was like last paper, paper, that was the highest I've ever seen. That's 65, and the lowest I've ever seen is 48. Okay, so 48 out of 100, which is typically considered fail, right, is actually an A here. Okay, and I think I told you what the reason behind that is. Reason to che, or students, at one point they just give up. Just stick with this paper or stick with this, topics out there. You should do very well. Now I'll explain why in a bit. Keno che, with the most minimum effort, you can get an A here. Okay, I'll explain in a bit. But yeah, are you clear about this paper? So this paper holds all the value. Whatever exam that you give, right? A paper is overall grade. So let's say you get an A in this paper, right? Even if you had a B in your AS, they go overall A through it is actually B or it can bring your ASA down to a B. Okay, so this paper holds the biggest value. You can see the percentage, it's like 40% of the exam, right? Why is it also possible to trick and hack your way around this paper? This paper has 16 questions, usually. Sometimes 14, sometimes 16, right? And every question has one definition. You had in your AS as well. First, second questions are going to definition, define this, write the equation like that. So 16 questions, right? All of the questions have at least one definition, 2 marks there, right? So how many marks do you have there? 32, right? So you can get 32 just by memorizing all the definitions out there. There are around 50 of them, right? Or 50 day ashe. So, just 32 there. And you just need to do some math and get how much more to get an A usually. Yeah, 20, 25. Okay. So that's why I've had students who have converted A's to A stars with this paper. Because, you can do really well here. And the advantage of your peers are usually not doing that well. Overall A tonic lona, people around the world are not doing really well in this paper. So you just set to above average put the pro, you can get a very big boost here. Okay, so yeah, just letting you know, A paper te shop kichu, and A paper to structured papers, so a lot of math, a lot of theory. Okay, no more MCQs. So oita night over there, whether you like it or you hate it. Yeah, so that is it. These are the 2 papers you have. So our main focus is just paper 4 generally target, right? Paper 4 we want to target 70 plus. So if you can get 70 plus in the mocks here, right? I can more or less assure you'll get an A. Okay, because that's how it is usually. Right, so that's the structure. These are the chapters out there. So those who join late, we have way too many chapters out there. There are some chapters that I've even combined to make it short because it doesn't even fit in the paper, right? So on thermodynamics, there are 2 parts. Ideal gases, there are 2 parts. Electric fields, there are 2 parts. And these chapters are not small chapters. They're the same volume of material as your AS chapters. Okay, so yeah, the challenge is that you actually need 2 years for this, A2 syllabus, but you only have 7 months. Okay, so that's the biggest challenge that we have. Right, so any questions regarding this? A chapters go to challenging quantum physics especially, and medical physics like the most hated chapter out there. It's you need to learn the working of an X-ray machine, an MRI machine, a PET scan machine, a CT scan machine, and the amount of detail that you need to learn is actually more than the people who actually perform the MRI and CT scan. Radiologists but then they work with the X-ray machine, right? So you need to know the inner workings of it, like the structure, the material, the science, the physics, everything. Okay, so yeah, each chapter okay, so that is one. And you guys didn't have astrophysics, right? So batch O level set. You're the first batch to have it. So did you do like star cycle and everything? I said, tell it this chapter okay, because this is a downgrade from your O levels. O levels se ja shikso oikhon theke khali ekta topic niye pura syllabus ta. It's something called a Doppler shift, redshift. This is just redshift. That's just the whole thing here. Okay. So yeah, A chapter you can cut it out if you had O levels astrophysics. There's O levels astrophysics at 5% Rest of these are all new chapters. I don't think anything that you can relate to. Nuclear physics, maybe you might have heard of the half-life, right? So half-life to mention, but na parleo nuclear physics parba. That's about it. Oh yeah, magnetic field. Magnetic field is actually a repeat of your O levels. This is one chapter I can say that it's O level version. So remember the left-hand rule, left-hand rule, right-hand grip rule, and everything. সব আবার করতে হবে, motor, generator, transformer সব আবার করতে হবে. But what's new tahale? The math. It's all math based now. So now you need to do calculations and find out FBI, what is the force, what is magnetic flux, what is the current, right? So it's the math, O levels and math student. Okay. Right. So what type of content? Yeah, it's I would say that there's a distribution. It's in your syllabus. I forgot to copy that part. তোমাদের mark distribution কি হয়? So structured, analytical, calculation এরকম একটা distribution দেওয়া থাকে। এটা you'd say 40% is math and 60% is theory. Okay, so 40% is just math calculation. So most students who do well ওরা ওই math থেকে ace করে, because the theory is actually very gray area. You know, you might think one way, the examiner thinks the other way, but math objective, everyone gets the same answer, right? So if you're good at math here and if you know your definition, right, I can give you a challenge. Like, you just go through the mark scheme, ignore all the theory, just add up all the definition and the math, right? You get an A. Okay, so theory টা হচ্ছে just bonus. সব theory তো না পারবা না, you get some that would be right? So overall you'll find that you can do really well. So yeah, that's it. Our the challenge is that students start to lose track. If you are consistent with the chapters, like as I do every chapter, if you just solve a few question papers and just have a basic idea of what's going on, it should be fine. Jeta hoy oy jai eseo koro tomra, around January you realize you have physics, and then you start to study, right? There's no catching up, absolutely no catching up. Okay, because the volume is so much. If you just read the book, right, and the notes, it'll take you 2 months. So, just read it. I'm not saying understand and, practice questions, just normal reading version, right? So the volume is the challenge. The only way you can overcome this is that as we do chapters, right, you also finish them all, like do question papers and stuff. So that later on is just a revision that you need to do. Okay. Don't keep anything for later on. That's the bottom line here. Right. So that is it. Any questions regarding the papers? So paper 4 is the target. Paper 4 is 100 marks. It's all structured question. It's 2 hours. Paper 5 টা হচ্ছে বললাম তো যে full marks is like a norm. Okay, and full marks না পাওয়া is like embarrassing. Okay, so it's a very easy paper. Graph plot করতে হবে, একটা planning করতে হবে। আর planning এ হচ্ছে I'll give you a checklist. ওই checklist যদি করে ফেলতে পারো, you have like 10 marks, 15 এর মধ্যে। বাকি 5 marks হচ্ছে diagram and analysis and stuff like that. Okay. There's an introduction of math in your physics here, higher math. So are you aware of logarithms? So dealing with logarithms, right? So this A level has a lot of logarithms. Okay, no differentiation or integration, but a lot of log-based calculation, linear log, logarithm, natural logarithm, polar related equations. Right. So if one gets B in AS, how much should they score in the paper to get an A? Depends. If it's a low B man hoche 70. 70 is like the boundary B, right? You have to get 90 in your A2, then it's an A. Okay. But to me 75. I had a student who got 78 and got an A star. So that's like 94 kilotar. So divided by 2, 94. So yeah, it's possible. When I'm saying this, just to encourage you that even if you have or got a grade in your A's, that's not something you anticipated, right? This paper can make a difference. Okay, and it's the only subject I've seen where it's possible. Like Excel or Cambridge or papers, it's not possible. But physics, it's possible because it's so heavily dependent on that one paper. Okay. Right, so let's start. Ashi will start with the first chapter because I told you we're already behind, right? So take out the book, go to page number 3. All right, let's start. Chapter to ki aage bolene. So this is from your syllabus as always. This is circular motion. Our first chapter. It's called circular motion, and it's actually an extension of your mechanics. So is a mechanics chilo, which are at extended part. If you recall, some of you will remember O levels also. You had circular motion and the idea of centripetal force, right? We am a revisit korbo, but this time again, as with every other chapter, what will we include? Math. Okay, so we'll be doing the calculations of circular motion. So first of all, we need to define the circular motion that we have in our syllabus. So obviously, circular motion means an object goes in circle, but there are a few more things that we need to know. So the first thing that you need to know is that we are not dealing with all types of circular motion out there. I'll explain. So let's say there's an object here and it's going in a circle. So this is the path it's taken, right? So that's your circular motion. Our syllabus will deal with, because this is just introduction, constant circular motion. So what's constant circular motion? Meaning the object will be going around in a circle at what rate? A constant rate. So there is something called accelerated circular motion, very complicated. Calculus chara possible now, it's that the object will be going slowly and then it'll start to speed up. Like how you turn on your fan and your fan speeds up to maximum speed, right? We don't have that, thank God, right? Our touch, it only goes in a perfect circle. So there are other paths an object may take and falls under circular motion where we don't have it. For example, elliptical orbit. Like, you know how your planets go, whatever the circular motion part, but it is skewed. It keeps going in like an oval, right? So it's a perfect circular motion that we have. A perfect circular motion, a definition of the first thing that you need to understand, this speed remains constant. Okay, and this speed has a name. It's called the tangential speed. আমি velocity constant বলতে পারবো না কেউ কি জানো কেন? We did this in O levels. Why can't you say velocity is constant? Yeah, because it's going in a circle, so there's continuous change in direction. So velocity can change, but the magnitude remains what though? Same. Okay, so my velocity will be 30 everywhere, but because direction is changing, the velocity direction change like the velocity of units. Okay, so the tangential speed is constant. So the speed here remains constant. Etar symbol হচ্ছে just v use করব. Okay, there are different names for it. I'll put the names down here. Tomre syllabus use for it. So tangential speed is one. Arekta হচ্ছে is also known as the instantaneous speed. So at any given point, what is the speed of the object? Okay, so that's your instantaneous speed. This is an object going in a circle. What are the features of the circular motion that we have? So features number one is that it is a constant rate circular motion. Okay, and number two complete circle. So it'll make circles, not arcs or not quadrant or a semicircle. It'll be doing full circles. Okay, because over math are two different way. So this is a complete circle. All right, let's have a look here. Right, show it, screen it too. So you have something going in a circle here. This is a blade of a fan. Okay, so একটা ফ্যানের ব্লেড হচ্ছে এভাবে সার্কেলে যাচ্ছে. Do you understand? মানে বুঝছো তো ডায়াগ্রামটা? So এখন question হচ্ছে how do we quantify circular motion? Because when you have a car going on a road, right, there are a few quantities you can use to explain what's going on. Like key with the right quantity. If a car goes on a road, right, can you tell me the quantities that I can use to explain what the car is doing? Speed, acceleration, displacement. So displacement tells me what? How far the car has gone, right? Speed tells me what? At what rate it has gone. and acceleration tells me what if that speed is like changing or not. So if I told you the if I tell you the displacement, velocity, and acceleration of an object, right, linear motion in it, everything is covered. There's nothing else to look into. However, in circular motion, the problem is that these don't work, and the reason behind that is as the blade goes around in a circle, right, and comes back here. Can you tell me what is the displacement? Zero, right? So if I told you I have a fan blade and I tell you what its displacement is, it's zero. So it could mean either of one of two things. It made a motion and came back to where it is, or it never started off, right? Because if it's zero, it could be just stationary, or it has been doing multiple cycles and it's coming back to the same place each time, right? So for circular motion, we have to come up with some other quantity, and that quantity is also not speed. I'll tell you why it's not speed. Okay. Think of this. There's a part of the fan that does this circle. Okay, so I'll draw the circle here. So yeah, this circle is part of the blade, right? So let's say there's a blue paint there that makes that circle, and there's a red paint here, and it smudges around, right? And it makes another circle. What I'm trying to do? Have you seen a pottery wheel? Pottery wheel is like a wheel where you make pottery and keep spinning, right? So if I place two ink dots there, right, and I smudge them, wouldn't they make circles, right? One would be a bigger circle, one would be what circle? Smaller circle. So imagine that, right? But here's the problem though, that when I spin this wheel, isn't the wheel moving at a constant rate and covering equal location every time? Isn't the wheel or this blade moving together? Is there part of the blade moving separately, or is it one thing moving together? One thing moving together, right? However, there's a small problem though. Problem hoche, if you look at this part, it creates a circle, and this also creates a circle, which are not what in length, right? Now the perimeter is different, right? So if you look at a circle, and if I tell you the fan blade, for instance, right, can you tell me which part of the blade covers the greatest distance? The edge, right? And which part of the blade doesn't move? The center. So if you had to put your finger into a fan, right, for whatever reason, where would you place your finger? Center. Okay, it could be a jet engine, right? 400,000 RPM. You can still put your finger into it. Where? The center. Center to move though, because the center it's spinning, but it's not moving. There's a difference. Okay, it's in its place only. But if you look at the edges, right, they're the fastest. So the problem is that if I told you the speed of objects here, right, you'd find eater speed ki same naki different? Different, right? What's the formula for speed? Distance by time, right? A blade ta jokhon ekta full circle kore, doesn't the time taken by the blade be same for all the parts? If you think of the red part that goes around and comes back here, and if you think of the blue part that goes around and comes back here, don't they take the same time? But they cover what distances? Different. So if I want to explain to you how the blade of a fan spins, and I told you the speed, right, would it be an accurate representation? No. Why? Because every part of the blade has what speed? Different speed, right? So therefore, speed doesn't work for circular motion. So if somebody asks me how fast the fan blade is spinning, and I tell you 0 meter per second, right, I'm actually correct. Which part of it is that I'm talking about? The center, right? But I can also say that the same fan also has a speed of 100,000 meter per second. Which part could that be? Something further away, right? So isn't it very vague what I'm trying to say? So how do we fix this? Now the whole conversation I'm having right now is to explain to you why traditional quantification doesn't work here. So the thing that we'll be looking into is what is same for both the points here. It's a pointer jonno or a red pointer jonno ki same. That would be a good quantification. Why? Because if it's same for all points, isn't it something that I can share? Because that will mean it's the same everywhere. So can you figure out what could be same? Time, right? Exactly. And that's why the first quantity that we have in circular motion is time period. So time period hoche the time taken for one complete oscillation. Okay, so time period at a capital T de dewa hoy. Time for one complete oscillation. So time period makes sense because the time period for the blue dot and the time period for the red dot, right, is what? Same. So, there's nothing vague about it. It's a uniform explanation, okay? So the first quantity that we have here is time period. Okay, let's look into the next one. Our key হচ্ছে same হতে পারে। এটা I would prefer যে you guys figure it out and চিন্তা করে দেখো। So এই blade টা এখান থেকে এখানে move করলো, right? What else could be same or is same for the blade other than time period? Sorry, radius. And radius is same. Radius তো এখানে আছে, forgot to mention. Radius is same. আর তো বলছে কি angle. Yes, very good. It's the angle. Okay, Keno, just imagine this. Okay, a blue. Yes. Right. So if I draw this line here, and this is the coverage of the blade. Okay, from the center to this point. So if you look at this line here, and if you look at the original line here, isn't every single part of the blade covering the same angle as they move, right? And that's why circular motion is the most important quantity is the angle that you cover. When it comes to linear motion, the most important quantity, I don't know if you know, is actually displacement. From displacement ke differentiate kore ki pawa? Velocity or speed. Speed ke differentiate kore ki pawa? Acceleration, right? So where does it all start at? Displacement. So displacement is the key to all kind of quantities in linear motion, right? For circular motion, displacement doesn't make any sense. So what becomes that key quantity now? Angle. Everything that we'll be doing from now onwards for circular motion will be based on angles. Okay. So you can a angle is same, and there's a name for this. We give a symbol theta. Okay, and this is called angular displacement. Angular displacement. This is the next quantity that's important for us. Angular displacement. This is the angle covered during circular motion. Okay. As I mentioned earlier, A2 is very, definition heavy, right? So all the definitions that we have always has a chance of coming in your exam. Okay. Eventually, I'll ask you to do like a, note down on all of them together for, your revision purpose. But শুরুতে আগে বলে রাখলাম. What's the symbol for angular displacement? So it's theta. I also forgot to mention the unit. So time period unit কি হবে? Seconds. Eighter unit to interesting. What is the unit for an angle? Degrees, okay? And turns out degrees is actually not useful in physics. Okay, so physics are not degrees used at all. You'll probably have had hint of this in your math. Math, you'll find that when it came to trigonometry and sine, cos, and tan and everything, right? What was the preferred angle? Radians. Okay, so everything in physics has to be in radians. Degree কাজ করে না. Okay, so the unit is going to be in radians. There's an odd thing about though. Do you know what the symbol for radian is? There's no symbol. What is the symbol? Acha, tomorrow the rad use karo. Yeah, RAD. But the official symbol is not actually this. Do you know what the official? It's actually a half C. মানে যে ডিগ্রি থাকে না 30 ডিগ্রি যেরকম রেডিয়ান এটা হচ্ছে 1.45 এটা ওকে এটা for some reason Cambridge follow করে না okay so if you don't know it's fine but তোমাদের সিলেবাসে কি লিখতে হবে rad okay radians so yeah that's the unit for angular displacement. Now if I want to know how fast something is moving, right, speed didn't work out. Remember what was the problem with speed? Speed is different everywhere. So I would rather find instead of the distance covered per unit time, what covered per unit time? Angle. Okay, because the angle is same cover হচ্ছে না. So the rate at which you cover angle is how you define circular motion, and this is known as angular velocity. Angular velocity কি হবে? Angular velocity is the rate of change of what? Angle. Okay, angular velocity. So yeah, these are the three quantities out there. This is rate of change of angle. And এটার সিম্বলটা হচ্ছে it's a symbol that students usually mispronounce. It's omega. But do you know what the symbol for omega is? Yeah, it's that, right? So that's omega, but that's capital omega. The symbol for angular velocity is small omega. And small omega is very commonly misinterpreted as W. It is not W, it is actually that symbol. তোমার সিম্বলটা যদি না বুঝো, I'll show you কোনটা। এই যে it's pixelated here, but do you see that symbol there? That is the symbol, okay? So আমি বলি কেন কি প্রবলেম, আমি বলবো যে omega equals to 2 pi by t, and then the student comes and tells me, but sir, I thought W equals to 2 pi by t. So, the confusion is like, omega or W, that's a confusion. They're the same thing, and the right pronunciation is what? Omega, okay? W na. So W, it's small omega. Now, yeah, when you write it as a small W, so on the syllabus allow for it, okay? But, as we discussed, keep in mind it's omega, okay? So omega is the symbol, and unit hoche, can you predict? Radian per second, correct. Greek W. Greek W exists for it. Right, so these are the quantities that you have, time period, angular displacement, angular velocity. Any questions regarding this? So from now onwards, whenever we define circular motion, we will use these three. Okay, so displacement equivalency ki ekhane, angular displacement, velocity speed equivalency ki ekhane, angular velocity and angular speed bole. We don't have acceleration. Okay, is there acceleration in circular motion? Yes, most definitely, but our syllabus doesn't have it. And আমি এটা উপরে হচ্ছে clarify করছি এই যে এটা constant rate, because if you want to introduce that, it becomes very complicated. Okay, so we don't have that. So yeah, our syllabus deals with objects just going in circles, because this is an introductory chapter for you. You're starting circular motion here, like not the complicated version. This is the basic part. So let's do a recap of this. Shall I screen it? So you have this object which goes in a circle, and the object will go from here to, let's say, there. As it does so, it will cover what here? An angle. And its tangential speed will remain what in our syllabus? Same, okay? So আমার যদি এটা v হয়, এটা still will remain what? V. But you can't say velocity is same, because what changed? Direction, okay? So yeah, that is it. This is obviously your radius, r. This is your angle, theta. And yeah, I think we have covered everything here. So yeah, this is the quantification. It's saying angular displacement wrong. No, angular displacement, the right way of saying it. Okay, so now we will derive our first equation. Okay, so there are total 5 equations from circular motion. We'll start with the first one. First one actually. So that is angular velocity. So definition of angular velocity is what? Rate of change of angle, right? So angular velocity, omega, will be equal to what? Yeah, angle covered or angular displacement by time, right? So angular displacement divided by time taken. What's the symbol for angular displacement? Theta, right? So theta divided by time taken is what? T. And that is the formula for angular velocity. Okay, so if you have angular velocity requirement in your exam, this is the equation. By the way, I forgot to mention something. Circular motion is going to be there in total 8 chapters. মানে আমাদের যে A2 chapter গুলো, out of the 16 chapters, 8 chapters have circular motion in it. That's why we are starting with this chapter. So this will be there in oscillations, gas laws, magnetism, charges, তারপর হচ্ছে nuclear physics এ নাই, you have quantum physics, astrophysics, right, gravitational field, সব জায়গায় হচ্ছে circular motion involved. So if you have confusion with circular motion, this will eventually start to creep up in other chapters as well. So that's why be very clear about what I'm doing here. If you have any confusion, clarify with me. কারণ এখানে যদি কোনো misunderstanding হয়, it'll show up in those chapters as well. Okay. So yeah, angular velocity is omega divided by t. Now, I said that in our syllabus, we deal with what kind of circles or what kind of circular motion, partial or complete. Right. So we can take a formula derive করতে পারবো আমরা, which is if your object undergoes a complete circular motion, right? Can you tell me what is the angle it covers in radians if you do a full circle? 2 pi. Do you know that? So a full circle is 2 pi, a half circle is pi, a quarter is pi by 2. Achha, pi by 2 is 90, pi by 4 is 45. So এই angle গুলো মনে রাখতে হবে. You had these thing in your As with phases. Remember phase difference, path difference. You have that in your A2 as well. Okay, so it revisit করবো, but not as complicated as As. It's much easier here, right? So can you tell me what is my theta going to be for a complete circular motion? 2 pi. And what is the time going to be? No, because it's a complete oscillation, right? There's a special name for that time period, right? And that's what capital T. And this is the most used equation of your A2. Okay, that's why I brought it up. The 8th chapter, 8th chapter A formula lage. Omega equals to 2 pi by t. Okay, so 2 pi হচ্ছে for complete circle, t is for time period. There's an alternate to this equation, যেটা অনেক সময় comes handy, but I think you can figure it out. Can you tell me what can this also be written as? অন্যভাবে simplify করা কি possible? Look at the equation. There's something here that you can simplify, or you can represent differently. No. My 2 pi by t formula. So there's another way of representing this equation. There's a hidden quantity here in this equation. It's correct. Okay. So what's 1 by time period? Frequency. And ওইটাই হয় যে হঠাৎ করে in your mark scheme you'll see 2 pi f and some students will go like, what is that equation, right? It is this equation. They just use it differently. Okay. So this is also an equation that you have. A frequency নাম হচ্ছে angular frequency. Yeah, no, RPS. Rotations per second. You said RPM, right? RPM is rotations per minute. A minute is not a standardized quantity. Right, so তোমাদের questions থাকলে বলো. This is the introduction to the chapter. আমরা হচ্ছে we'll build on whatever we have learned here. So I'll do a quick recap of it. We're dealing with circular motion, right? And we're dealing with what kind of circular motion? A perfect circle, okay? Like, full radius constant থাকবে. There are possibilities where things spiral out. Do you understand what I'm trying to say? So if something is speeding up, right, because it spirals. Have you seen, like, let's say when you have a ball and there's water in it and you spin the ball, water splashes out from the edges, right? Or if something is spinning, you'll see water droplets flying out. So this is called spiraling out, and it usually happens when things speed up, right? We don't have that, okay? However, they can give you questions based on theory on it, no math. The theory থাকতে পারে. If something starts to spin faster, right? What would you observe? So you might observe sometimes things flying away, right? And why does that happen? Because it's speeding up. Clear? So there's this experiment I'll be showing you. You take a pendulum, right? And you spin it very slowly. you'll notice it's doing like a small circle, and you start to spin it faster. What does it do? Yeah, it starts to rise up, right? And you spin really fast because it's becoming flat. And that's like how helicopter blades work. Because they're usually like that. And as they start to spin, or why? Because of the external. We'll learn about it, centripetal force and centrifugal force and whatnot. Okay. So yeah, in math we do not have it, but in theory we have it. Okay. So yeah, we have perfect circular motion. And we assume that at least in our math calculation, that the objects are undergoing rotation at what rate? Constant rate. Okay, could be important. Because if you try to think other way, you'll find the question get complicated. And to define circle and circular motion, we have three quantities out there. In total, four are techno-coordinate. So you have time period, which is the time taken for one complete oscillation. You have angular displacement. Angular displacement essentially is this. That, okay? So this is your angular displacement. just বলে রাখি because I've seen questions arise on this. আমি একটা জায়গায় shade করব. Can you tell me what would you call this? Yeah, it's called arc length. Okay. So do you know formula for arc length? Arc theta. Theta is what? Theta by 360 to 2 pi r. That's the derivation. Yeah, so arc length is S equals to r theta. Have you seen this before? So এটা মাঝে মাঝে লাগে. I have not seen it show up that often, but it's part of your syllabus requirement. Okay. So arc length. Right, so that is it. And angular velocity হচ্ছে এটা, like how fast is the object moving around, the rate at which the circle is being covered. Okay, so that's your angular velocity. Unit হচ্ছে radian per second. And from there, you can derive the formula for angular velocity. This is our first official equation. Omega equals to 2 pi by t, or omega equals to 2 pi f. Here. Right, so I'll be starting something else, but ask you to just discuss coordinate. In syllabus, they ask for a definition, which is define the radian and express displacement in radians. Express displacement in radians, which is basically, can you convert an angle into radian? How do you do that? 45 degrees. How do you convert that into radian? Pi by 180 into 45. Yeah, okay. So how to convert degree to radian? It is into what? Pi by 180. It's basically unitary method. Unitary method pi represents what angle? 180. So whatever you're looking is x, and you can use unitary method. You can make it into a formula as well, but it's generally just unitary method. So pi camera key they represent 180. So similarly, 2 pi would be how much? 360 and so forth. Okay, so questionটা হচ্ছে এটা আমরা দেখবো, এটা আমরা নেক্সট ক্লাসে আবার করবো এগুলা, বাট এই জিনিসটা কি তোমরা জানো what is the definition of a radian? It is the most random question they have in your syllabus. It has nothing to do with physics. So does anyone know what is a radian? A math directed question. Surprisingly, every time I ask the question, there's somebody who knows it. So anyone knows it? Because I wouldn't really expect anyone to know this. It's the definition of math. Math definition no, right? So why would you know? But students know. So what is a radian? 57 degrees. 1 radian. But do you know what the definition is? Anyone? Angle between two vertices. No? Yeah, I know. So, surprising. Which I think is normal. I don't know why they know it, because it's not supposed to be a thing. Basically, a radian is the angle subtended money created, okay, at the center of a circle, such that the radius is equal to the arc length. So তোমরা একটা সার্কেলের যদি রেডিয়াস r হয় আর আর্ক লেন্থটাও যদি r হয়, যে অ্যাঙ্গেলটা ক্রিয়েট হয় is what? 1 radian. That's the definition. So 1 radian is the angle subtended at the center of a circle such that the radius and the arc length are what? Equal. So yeah, this is one random derivation out there. There's no use of this in physics, okay? But they ask this quite often, okay? So yeah, we'll go to the next class. Ajke ekটু কি রাখি because I think for a first class that's a lot. So yeah, we'll recap this next class, okay? I'll stay restricted add you right now with a code. If you haven't received your Google Classroom invitation into front desk, follow.